Hi, welcome to my channel Cloud with Girish. In my previous video, I demonstrated a recursive loop scenario with AWS Lambda and showcased the configuration that help detect and prevent such loop in an event-driven architecture. For that demonstration, I created a SQS queue and a Lambda function using the AWS console. I recommend watching the previous video to gain context for this topic. In this video, I will recreate the same recursive loop scenario using AWS SAM. This means I will define and deploy the SQS queue and Lambda function using an infrastructure as code approach. The template.yaml file will specify the resources to be created. Before diving into the implementation, I will share a recap of what a Lambda recursive loop is and review an example of an event-driven architecture that could trigger this scenario. Let's look at our architecture. We have an SQS queue. This is a contact queue where contact data get dropped. This contact queue has an event mapping with a Lambda function. Lambda function has the code to process the new message, and then it's supposed to publish it to another destination queue. However, due to a bug, Lambda is publishing the message again to the contact queue. And now this will create a recursive loop because the publishing of a message in the contact queue is triggering the Lambda. Lambda is again putting the message back on the same contact queue, and then contact queue again invoking the Lambda. So it's a recursive loop scenario. Before implementing the function, let's look at the prerequisite. Need to have familiarity with the AWS Management Console, a basic understanding of AWS SAM, and a basic understanding of Lambda function, event-driven architecture, and Python programming. Let's get started. We're going to look at an intro to Lambda recursive loop. We're going to look at an example of recursive loop in an event-driven architecture. We'll look at few points about recursive loop, and then we're going to review the template.yaml file. This is the file that's required to implement the AWS SAM. We're going to look at the SAM code to create SQS queue. We're going to also look at a portion of the code that create the Lambda function. And then we're going to look at the SAM code to create event mapping between Lambda and SQS queue. I'm going to build and validate the Lambda function using the AWS SAM. And then I will deploy the function to AWS Cloud using AWS SAM. Once we have deployed the function and the Lambda, the SQS queue will trigger the event by publishing a message to SQS queue. I will publish the message using AWS CLI. And then at the end, we'll do the cleanup, which is basically deleting the Lambda function and SQS queue. So let's first look at what Lambda recursive loop is. A Lambda recursive loop refers to a scenario where a Lambda function is invoked recursively, creating a kind of infinite loop. Now it's similar to a do-while loop without an exit condition. So one event is triggering a second event, and that is again triggering the first one, right? So it's like a keep on going in a loop. In an event-driven architecture, this situation can arise when services like SQS and Lambda unintentionally invoke each other in a loop. For example, consider the following scenario. A message is published to an SQS queue. So in our architecture diagram, this queue was contact queue. Now this SQS queue is configured with an event trigger to invoke a Lambda function for processing. Now the Lambda function then publishing the message back to the same SQS queue. And this is basically due to a design flaw, code bug, or any other reason. But this is going to create a loop where the message continuously cycle between the queue and the Lambda function. Now, if this left unchecked, this recursive loop can consume your account allocated concurrency, leading to throttling and timeout. It will dry up the cost, and then it will negatively impact the other critical application functions by monopolizing the available resources, because now everything is being consumed by this recursive loop. Now, AWS announced the support for Lambda Recursive Loop configuration in July 2023. This feature enables you to detect and prevent a recursive loop in your Lambda function. Now, by default, this configuration is enabled for all accounts, ensuring that Lambda function automatically detect and stop infinite loop. Supported services as of January 2025 are Simple Queue service, Simple Notification service, and Simple Storage service. So SQS, SNS, and S3, of course, along with the Lambda, because that's how the event mapping will be created. Key point to consider when you are looking at Lambda recursive loop configuration. So first thing to know is that Lambda recursive loop configuration is enabled by default. So if your business use case requires disabling this feature, then make sure that you have alternative guardrail in place, such as you are monitoring the budget, you are monitoring the function invocation, you have like some CloudWatch alarms, because you are intentionally creating the recursive loop. With the detection and handling, Lambda detect recursive loop from the same event and then stop the invocation after it exceeds 16 attempts. So what that means is that even if it's on by default, the recursive loop will continue until it exceeds the 16 attempts, and then it will stop it. Now once it stops, then there are some notification and metrics that you can look at. So when a recursive loop is detected, AWS will send a notification to your account health dashboard under the other notification tab. And then an email is also sent to inform you of the detection. The point to consider is the email is sent once in 24 hours, and it may take up to 3 hours to arrive. So like within that 24-hour window, if there is another recursive loop, then you will not get that email. And then of course, you can create your own notification by monitoring the metric. So there is a recursive invocation drop, so you can monitor it. You can also monitor invocations and build your own notification mechanism, right? So all those options are there. To create the recursive loop scenario, I need to create a SQS queue and a Lambda function. SQS queue will be a standard queue, and I will name it contact queue. Contact information, including phone number and name in JSON format, will be published to this queue. Once a message is published, it will trigger a Lambda function for further processing. The use case for the Lambda function is to publish the contact information to another queue for final processing. However, in this scenario, I will intentionally publish the message back to the contact queue to simulate a recursive loop scenario. The function will be named contact example, and I will select Python 3.13 as the runtime. Since I am using AWS SAM to create both the SQS queue and the Lambda function, let's review the template.yaml that defines these resources. This is our template.yaml, and this YAML is defining the resources needed to create the scenario. So let's look at our first resource here. Here is our SQS queue that's getting defined. It has the standard parameter that are required for the SQS queue. So visibility timeout, the delayed second, the message retention period, and so on. And then I have the Lambda function, which is getting defined with the runtime of Python 3.13. And then we have the timeout and few other parameters here. Also, there are policy applied, and that's needed just to make sure that Lambda function actually has permission to send message to the SQS queue. let's look at more on this template.yaml. So we need to create an event source mapping between SQS and Lambda, because this configuration ensures that the Lambda function is triggered whenever a contact is published to the contact queue. So here we will see that there is a configuration settings which is saying recursive loop terminate. That means that if it detects the recursive loop scenario, then Lambda function will terminate that loop, right? And then we also have event source mapping. So here we're saying that, hey, the event source mapping is the SQS. So basically what that means is that this Lambda function has the event source mapping with the SQS queue. So we need to ensure that Lambda function has the necessary permission to publish message to the contact queue, and also like we need to ensure that recursive loop termination is enabled. This is configured by default, but it's a good practice to verify it. So here that's exactly what we are doing. So we know that our recursive loop configuration is set to terminate. That's what we want. And then we of course have the policy permission to ensure that between Lambda and SQS, the event get triggered and it functions as intended. Now next we're going to build and validate. So since I'm using AWS SAM for this function, I'll begin by building the function. To build a function, the entire template.yaml resource, the command is SAM build. So if I run the SAM build command, I expect to see build succeeded, right? So if the message is like errors, then we need to go back and look at why the error is happening. But in this case, build succeeded. So that means that it's ready to be invoked. The function is ready to be invoked. If I just want to invoke the Lambda function, the command is SAM local invoke, and then you give the function name. So in this example, like SAM local invoke and my function name. But if I do invoke it at this point, because I'm not passing any event JSON, then I will see the message which say, hey, missing phone or name. And this is based on how the error handling has been managed inside the Lambda function. Once I know that my function is built and I have done the initial validation locally, it can be deployed to the AWS cloud using the SAM deploy command. So here is the command SAM deploy, and I can do SAM deploy command here and provide the information. And once this deployment is completed successfully, after that, if I log into AWS console and if I go to the SQS queue section in the console, I will see that queue has been created. And same way, like if I go to the Lambda function console, then I should see the Lambda function there. And both of these resources, including the event source mapping, has been created using AWS SAM. So this is a brief workflow is demonstrating how to create, validate, and deploy Lambda function using AWS SAM. So by leveraging AWS SAM, like any other infrastructure as code framework, you can streamline the development process and ensure that your functions are tested thoroughly before deployment. Now I have my Lambda function, I have the queue, so I have the event source mapping. So in order for me to trigger the event, I need to publish a message to SQS queue. So in this case, I can log into AWS console like I did in the previous video and just publish the message using the AWS console. But I wanted to show a different way to publish the message, and that's why I'm using the AWS CLI here. So here is the command to publish the message using AWS CLI. So I'm saying, hey, AWS SQS send message. Here is the URL for the queue. And I got this URL by going to the console, and I just copied it from there. And then I'm passing the message. So if you recall from the our use case, we need to publish the contact information, specifically the name and phone. So I'm publishing the name and phone in the JSON format, and this will get published to our contact queue. And because of the event source mapping, the queue will trigger the Lambda function, and Lambda function has the code to publish the message back to the same queue, and that's how like the recursive loop scenario is getting created. Now we do have the recursive loop terminate feature enabled. So what it will do is that after the 16 invocation, it will basically terminate the loop, and that's the safety feature that we have. How do we know that it has been terminated? Well, that's where the monitor and notification comes into the play. So once a recursive loop is detected, you will be notified through the AWS Health dashboard and via email. So Health dashboard notification, if you go in the other notification tab, then you will see that something like this, where it's gonna say that, hey, the recursive loop scenario has been noted. And then same thing for the email notification. You will see that an email has been sent to the account owner notifying them that a recursive loop has been detected. And an example of this email is like this. Now, in addition to the default notification, you can also set up custom monitoring by observing the Lambda function invocation, specifically the recursive invocation dropped metrics. Now, once we're done with this, of course, like I always recommend, that do the cleanup exercise. So delete the resources which are not needed. That way, like, you will avoid any unnecessary resource usage and the cost, right? So delete the Lambda function, delete the SQS queue. If you created any new role during the process, then remember to delete that as well. Now, since in this example, I use the AWS SAM, it's an easy process for me because I can simply delete the entire stack using the AWS SAM command, and command to delete all of that is just SAM delete. So if I run the SAM delete command, it's going to ask me for confirmation, and then it will delete the entire stack that it has created. Of course, my other option is to just delete the resource one by one using the AWS console. In this workshop, I demonstrated how to validate a Lambda recursive loop configuration using AWS SAM. I used a SQS queue and Lambda function event mapping to create a recursive invocation scenario. The entire configuration and validation steps, including the creation and setup of SQS queue and Lambda functions, were done using the AWS SAM. I hope you found this tutorial both helpful and informative. I'm constantly working on new content covering various AWS topics, so please take a moment to like this video and subscribe to the Cloud with Girish channel. Your support helps me continue creating valuable AWS tutorials and workshops. Stay tuned for more exciting content. Thank you.